Expected sir. I am Sridhar from Mechanical Engineering from SRIT College. Today, my topic is demonstration of gyroscopic effect using rotating wheel experiments. Today, we discuss about this topic is demonstration of gyroscopic effect using rotating wheel experiments. Introduction to gyroscopic effect. The gyroscopic effect is the phenomenon where a spinning object resists change to its axis of rotation. It is a fundamental principle observed in rotating bodies like wheels and gyroscopes. Understanding this effect is essential for applications in navigation, aeros- aerospace, and engineering. Introduction to gyroscopic effect. The gyroscopic effect describes the behavior of spinning object when subjected to external forces. It is a fundamental principle in physics that explains the stability of rotating bodies. Demonstrating this effect helps in understanding applications like gyroscopes and stabilization devices, like gyroscopic effects on ships, steering, front and back and bow, like pitching, rolling. This is the no compression effect in the rolling in gyroscopic effect. Basic concept of a gyroscope. A gyroscope is a device that utilizes a spinning wheel or rotor to demonstrate gyroscopic stability. When the rotor spins rapidly, it maintains its orientation due to angular momentum. This property allows gyroscope to detect and measure rotational movement. Purpose of the experiment. The experiment aims to demonstrate the gyroscopic effect using a rotating wheel. It helps visualize how a spin wheel resists tilt- tilting or changes in its axis of rotation. The setup provides a practical understanding of gyroscopic stability and precision. Principles of gyroscopic motion. A spinning wheel tends to resist change to its axis of rotation due to angular momentum. The direction of precession is perpendicular to the applied torque. The magnitude of the effect depends on the wheel's rotational speeds and mass distribution. Equipment required for the experiment. A study support stands with the horizontal axis for mounting the wheel. A rotating wheel or disc with adjustable rotational speed. A protractor or angular measurement device to observe precision angles. Setup of the experiment. Mount the spinning wheel securely on the support stand with axis horizontal. Spin the wheel at a desired rotational speed using a motor or hand pin. Apply a gentle force or torque to observe the gyroscopic response of the wheel. Effect of gyroscopic pull on a disc is fixed rigidly at a certain angle to a rotating shaft. Consider a disc fixed rigidly to a rotating shaft such that polar axis of the disc makes an angle with the shaft axis as shown in the figure. As shown in the figure is the cos theta, the polar axis, shaft axis is the sin theta. Direction of weaving, direction of axis is the diagram represents to the gyroscopic effect on rotor. Demonstration of procedure. Spin the wheel to the required speed and ensure it maintains a steady rotation. Apply a small perpendicular force to the wheel axis to induce precision. Observe the change in the wheel's axis and the direction of precision. Observations and results. The wheel axis does not tilt in the direction of applied force but precises around a vertical axis. The rate of precision increases with the applied torque and decreases with higher rotational speeds. The experiments usually illustrate the resistance of a spinning ball to change its orientation. Counter steering. This is the observation. This is the bike, car or aeroplane, ships. This like the observations. Factors affecting gyroscopic effect. The mass distribution and the motion, moment of inertia influences the gyroscopic stability. Like I section, T section, L section is the moment of inertia in gyroscopic effect. The rotational speed directly affects the magnitude of the gyroscopic torque. External factors like friction and air resistance can slightly alter the results of gyroscopic effect. Real world applications of gyroscopic effect. Gyroscopic effects are used in navigation systems for ships, aircrafts, and spacecraft. Stabilization of bicycles and the ships relies on the gyroscopic principle. Modern smartphones utilize gyroscopic sensor for orientation direction. Like the steering, we visual on the screen, like real applications of gyroscopic effect. This like conclusion and summary. The demonstration clearly show how a spinning wheel resists change in its axis due to angular momentum. The gyroscopic effect is crucial in many technologies and engineering applications. Understanding this effect enhances our comprehensions of rotational dynamics and stability. The gyroscopic effect, less noticeable than other three. Procedure a left weighing motion when pitching down and a right weighing motion when pitching up. Effective force in the aeroplanes. References Halliday, Ren, Resnick, Walcott 2014 Fundamentals of Physics. Okay, thank you, sir.